All right, so this is E1.11, which is our introduction to circles. We're going to go through how to write the standard form of a circle, and then show how we're going to use it in different ways. Okay, so the first thing we need to know is the definition of a circle. The definition of a circle is all points that are units from a center point which we call HK. Okay, so all points that are R units away from the center point. So notice if you look at our little picture here, HK is in the center, and if I go out a distance of R, I hit a point on the outside of the circle. So no matter which direction I go out R units, that's going to give me all the points to this circle. Okay? So that's all that's saying. So then we want to figure out, well, what is the standard form of a circle? How could we find this radius if we needed to? Okay, and we could find that using the Pythagorean theorem. Right here, I picked 2 points. I have my center and this point on the outside when I went out R units, and I can drop it down and make a triangle. Right? If I use the Pythagorean theorem, which says that a squared plus b squared equals c squared, I need to know the sides, the length of all the sides of my triangle. So notice this vertical edge right here. If I wanted to find the change in y, how many units is here, I could count them if I knew what these numbers were, or I could just subtract my y value. So this is a distance of y minus k, and the same thing with our vertical distance. This is a change in x of x minus h. Okay, I just see how much have those points changed by subtracting them. So I know the vertical length, I know the horizontal length, and I'm calling my hypotenuse r. So if I plug those in, I would get x minus h squared plus y minus k squared equals r squared. And notice this happens to be the standard form of a circle, which I'll write down in just a second. But I also want to point out, notice with it being r squared, if I wanted to solve for the radius all by itself, I would have to take the square root of both sides, right? And if I were to take the square root of both sides, what I would end up with is x minus h quantity squared plus y minus k quantity squared, all under a square root equals r. Notice this is our distance formula. Okay. So finding the radius is exactly like finding the distance between the center to the outside point of a circle. Okay, so we're going to use that a lot, but for now I just wanted to use a Pythagorean theorem to show you where the standard form of a circle comes from. So standard form of a circle is x minus h squared plus y minus k squared equals r squared. Okay, and this is where the point HK is the center, okay, and r is the radius. Okay. Now, the standard form of a circle you will need to know. This is uber important, and anything we do with circles, you need to know the standard form of a circle. So I'm going to go ahead and just put a star here and put memorize for the exam. Okay. Everything will ask you to put your center and your radius into the standard form of a circle, or you'll be finding the standard form of a circle, or you'll be given the standard form of a circle and being asked to do something with it. So very important that you know this is the formula where HK is the center and R is the radius. Okay, so let's go ahead and move down and look at our first example. Here it just says find the standard form of the equation for the circle described below. So anytime it asks me for the form, the standard form of the equation, I'm going to go ahead and just write what it is, because the more we write it, hopefully the easier we can remember it. Okay, so here's my standard form of a circle. Now this is my center, so I know this is H and this is K, and my radius they tell me is 2, so that's my R. So all I have to do is plug it in. X minus the H that they gave me, which is -2 squared, plus Y minus the K value that they give me, which is 7 squared, equals my radius, which is 2 squared. And then I just simplify. So I end up with x plus 2 quantity squared plus y minus 7 quantity squared equals 4. Now in my math lab, I will note sometimes they leave their answers like 2 squared. They don't turn it into 4. That's fine. On an exam, I prefer that you write it as 4, but if you leave it as 2 squared, I'll accept it just because that's how my math lab shows it sometimes. Okay. So this is the standard form of our circle. And then I just want to point out, notice whenever it's in the standard form of the circle, whatever our numbers are in our quantities here, in our squared quantities, that tells us our center. Okay. The only difference is when it's written in the equation, the signs are flipped. So if you're ever given the standard form of the circle and you want to find the center, you just take the numbers that are in your squared quantities and change their sign. So here my center would be negative 2, 7, which obviously we already knew because it was given to us. I'm just pointing it out. Okay, and then our radius, we look at our constant term on the other side. This is actually our radius squared, so then we would have to figure out that if r squared gives you 4, then that would mean r has to be 2. Okay, let's look at another one. They give us the center, they give us the radius, we plug it in and find the standard form of the circle. So I have x minus h quantity squared plus y minus k quantity squared equals r squared. Here my h is 5/3, my k is 8/5, and my r is square root of 8. So I go ahead and plug in what I know. So x minus my h, which is 5/3 squared, plus y minus my k, which is 8/5 squared, equals my radius, which is the square root of 8 squared. And then I just simplify again. So here I have x minus 5/3 quantity squared plus y minus 8/5 quantity squared is equal to, now here when I square a square root, they just cancel and I get 8. So this is the standard form of my equation. And then just like before, I'm going to go ahead and highlight how quickly it is to see what our center and radius are when it's written in this form. Okay, our center, we take the numbers inside our squared quantities and just change their sign. So this would be a center of 5/3 and a center of 8/5, which again we knew because that was given to us. And then here our radius, this is our r squared. So if when I square r I get 8, that would mean r has to be the square root of 8. Okay. So once it's in the standard form equation, then it's really easy to see our center and our radius, or conversely, it's the same if we have the center and the radius, it's really easy to put it in the standard form. Okay, so let's go ahead and move on. The next thing we're going to look at is when we are given only the endpoints of the diameter of a circle, how to get it into standard form of the equation. So what I'm going to go ahead and do is I'm going to go ahead and just draw a little picture. Okay, if I draw a picture, let's pretend this is my circle. Okay, the diameter, remember, is the distance all the way across. Okay, the diameter is twice the radius. Okay, the radius, remember, is just from the center out to one side. Diameter is all the way across. So they're telling us that they're giving us the endpoints of the diameter. So they're giving us this point and they're giving us this point. And we have to figure out how to get it into the standard form of the equation for a circle. Now, in order to put it in the standard form, just like before, we need to know the center and we need to know the radius. So the first thing we're going to do is we're going to find the center. Okay, because if I find this midpoint, okay, that gives me my center value, my HK. And we do that by finding the midpoint. Remember, the midpoint, we do x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So we're just finding that middle ordered pair. And when we find that middle ordered pair, this gives us the center. This gives us the center, which we're going to label HK. Okay. Now, once we know the center, just like the last few examples, we take the center and the radius and we plug them into the standard form. So now that I know the center, I need to know the radius, which is this distance right here. Now to find the radius, remember, we're going to use the distance formula. Okay. We're going to go ahead and use the center, which was HK, and 1 of the endpoints, which we're going to say xy, and plug into the distance formula to find r. So remember again, r is equal to the square root of x minus h squared plus y minus k squared. Okay, so we're calling this point over here just xy. And then we know our center is hk, and to find the distance between 2 points, we just subtract their x's and square it, subtract their y's and square it, add that together and take the square root. So now that we have the center and we have the radius, now we just plug it into the standard form of a circle equation, which is x minus h squared plus y minus k squared equals r squared. Okay, and then I'm just going to say, then simplify. Okay, so let's go ahead and look at one doing this process. So here it says the standard form of the equation of the circle. That's what we're trying to find, and it's described below. So they're giving us the endpoints. Anytime they give us the endpoints, the first thing we need to do is find the center, the point that's the midpoint of those two. So I'm going to go ahead and put here, we're finding the midpoint, which is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So here if I add my x's, I have 0 and 8. I'm going to divide that by 2. And my y's, I have 6 and 0, and divide that by 2, which gives me the point, excuse me, 4, 3. Okay, so this is my center, or in other words, my HK. So now I have my center. Now I want to use that center and one of these points to find my radius. Remember, in order to find the radius, we're going to use the distance formula. So our radius here, I'm going to go ahead and say use center, which is our HK, and a point, which I'm just going to choose this first one. Okay, so I'm going to say 0, 6 to find our radius, which is r. So r is equal to the square root of x minus h quantity squared plus y minus k quantity squared. So plugging in my values, my x that I chose is 0 minus my h value, which was 4, remember from my center over here, squared, plus my y value that I chose, which is 6, minus the y value from my center, which is my k, which over here in brown is 3 squared. And then I just simplify. So I end up with negative 4 squared plus 3 squared. And I'm just going to move over because I guess I can just do it right here. Which is the square root of 16 plus 9, which is the square root of 25, which is just 5. Okay, so that means that my r equals 5. So I know my center and I know my radius. So just like the last example, now that I know my center and my radius, I'm going to plug it into the standard form of a circle, and that will give me my answer. Okay, so I do x minus my center x value, my h, which here is 4 squared, plus y minus my center y value, which is k, which in this case is 3 squared, equals my radius, which is 5 squared. And then I'm going to go ahead and simplify. So I just get x minus 4 squared plus y minus 3 squared equals 25. And I can just leave it like that. Okay, let's look at another one. Same process. When they give us the endpoints, we find the midpoint, which gives us the center, and then we use that center and one of the other points and find the distance between, because remember the radius is the distance between the center and an outside point. Once we have that distance, we have the radius, and then we just plug the center and the radius back into our standard form of the equation for a circle. Okay. So let's look at another one. First thing I need to do, given the endpoints, is to find the midpoint, because remember the midpoint gives us the center. So I do x1 plus x2 divided by 2, y1 plus y2 divided by 2. So here if I add my x's, 5 plus 8 divided by 2, and I add my y's, 3 plus negative 3 divided by 2, I end up with the point 13 halves and 0 over 2, which is just 0. Okay. Okay, so this is my center, or my HK. Now that I have my center, I need to find my radius. In order to find my radius, I use my center, my HK, which we just found to be 13 halves and 0, and a point, which I'm just going to choose the first one. Okay, so I'm going to use 5, 3, and I'm going to plug in for R. So R is equal to the square root of x minus h squared plus y minus k squared. So when I plug mine in, my x that I chose is 5, minus my h, which is the x value of my center, which is 13 halves, squared, plus my y value that I chose, which is 3, minus the k value, which is the y of my center, which is 0 squared. And then I just need to simplify. Now here you don't want to get a decimal because you're solving for your radius, and sometimes these decimals will repeat and turn into nasty things. So go ahead and write this getting a common denominator. So here if I get a common denominator, this is the same as 5 over 1 minus 13 halves squared plus 3 squared. My common denominator for 5 and 13 halves would be 2. So I would multiply on top and bottom by 2, which gives me 10 halves minus 13 halves squared plus 9. I'm going to come up here and run out of room. So I have R is equal to the square root of 10 halves minus 13 halves is negative 3 halves. And then I'm going to square that and add it to 9. Now when I add it to 9, I'm going to have the same problem. I'm going to need a common denominator. So here I get 9/4 plus 9 over 1. 9 over 1, to convert that to a fraction with a denominator of 4, I need to multiply on top and bottom by 4. So I get the square root of 9/4 plus 36/4. Okay, which means that my radius is the square root of 45 over 4. And I'm not going to simplify that because I'm just plugging it into the standard form of the equation. And remember, when I plug in R, it gets squared. So it's going to get rid of that radical anyways. So I'm going to take my center, which I found, and the radius that I just found, and plug it into my x minus h squared plus y minus k squared equals r squared. So here my x minus my h, which in this case is 13 halves, squared, plus y minus my k, which is 0, squared, equals my radius, which is the square root of 45 over 4, squared. Whoops. Okay, and then I simplify. So that leaves me with x minus 13 halves squared plus y squared equals 45 over 4, because the square and the square root cancel. Okay, not too bad. Another thing I want to point out is anytime you see the standard form equation of a circle and you don't have a quantity, like here we just have a y squared, we don't have quantity y minus something, that tells us that its center value has a 0, right? That's the only way that you would not have a quantity here, is if you're just subtracting a 0, right? All right, let's keep going. Let's go ahead and move on to finding the standard form of the equation for a circle tangent to a given line. Now, the first thing I need to point out is, what does it mean to be tangent to a line? When I say that a circle is tangent to a given line, that means that the circle and the line touch at one point. Okay, so I'm just going to say means the circle and the line touch at one point. Okay, so if this is the line we're talking about, and like say our center's here, then we know our circle has to look something like this, because we know it has to touch that line at one point. Okay, so let's go ahead and look at one. Here it says the center is 7, 2, so right away I go ahead and I know my HK, and it's tangent to the x-axis. So remember, x-axis is our horizontal axis, so somewhere on this axis there's a point that falls on this circle. So I'm going to go ahead and plot my center, which is 7, 2. So I'm going to the right 7 and up 2. 1, 2, 3, 4, 5, 6, 7, up 2. So there's the center. So if I go the closest route from my center down to the x-axis, that hits right here. So that has to be the point, excuse me, that the line and the circle share. So the next thing I need to know is what is my radius? Because in order to write the standard form of the equation, I have to know my center and I have to know the radius. So this one's easy enough. If I just draw a line between those 2 points, I can easily see that my radius is 2. Okay. So if my radius is 2, now I just plug those into the standard form of a circle. So if I do x minus h squared plus y minus k squared equals r squared, my center, x minus my h, which is 7 squared, plus y minus my k value, which here is 2 squared, equals my radius, which is 2 squared. So that gives me 4. So this is the standard equation for this circle. And then I'm going to go ahead and just draw it. Since it's already there and I know my radius is 2, I can go out 2 in each direction. And then draw, hopefully, a pretty decent circle. There we go. Okay. And I like to label my center and my radius whenever I graph a circle. But since this one's so big, I don't know if I can squeeze it in here. This would be 7, 2. And here my radius is 2. Okay. Let's look at another one. This one says the center is 3, 5. So I already know my h and my k. So all I need to figure out is my radius. And this one says it's tangent to the line x equals 1. So the first thing I need to do is graph this line. Now, x equals -1 is just, there's no y value. So that means it's a straight vertical line through -1. So I'm just going to say graph this vertical line. So if I go to x equals -1, that's here. So this is just a straight line through x equals -1. Okay, so somewhere on this line, this circle has an endpoint that touches it. So I'm going to go ahead and graph my center, which is 3, 5. So I'm going to the right 3 and up 5. 1, 2, 3, 1, 2, 3, 4, 5. So here's my center. So I'm going to go the shortest distance from my center to this line, which would be this point right here. And that must be the point that they share. Again, I just connect the 2 lines to see what my radius is. So if I connect those, I can easily count. Now, if they land somewhere funny, like if this was like x equals negative, I don't know, fraction, and maybe my center had a fraction, then you might want to do the distance formula to get this exact radius. But I'm pretty sure all the ones that they give you hopefully will be countable. So here, if I just count my distance, I have a distance of 1, 2, 3, 4 units. So that means that my r is 4. So I'm going to go ahead and plug in what I know to get my standard form of the line. So x minus h squared plus y minus k squared equals r squared. So x minus my h, which is 3 squared, plus y minus my k, which is 5 squared, equals my radius squared. So 4 squared, which is 16. Okay, so there's the standard form of the circle. And since I know my radius is 4, I'm going to go ahead and go out 4 in every direction so I can graph this circle. And then I just connect my circle. Make sure when you draw your circle, it looks like a circle and not like a rounded square or a diamond. Okay, my center here is 3, 5, and my radius is 4. Okay, not too bad, hopefully. The next thing I want to look for is actually an easier example than the ones that we've previously done. This is finding the standard form of the equation given the center and a point that the circle passes through. Now the center, remember, that's our HK, and a point the circle passes through, that's just an endpoint. So if we already know the center and the endpoint, what we've been given is this point and say maybe this point. So all we need to find is basically the radius, and then that way we can plug it in to our standard form of the equation, and then we're done. So it says use the points to find the radius. So I'm going to use HK and that point xy, so that's whatever point's on the edge of our circle, and I'm going to plug it into r is equal to the square root of x minus h squared plus y minus k squared. And that will give me my radius. And then once I know my radius, and I already have my center because it was given to me, then I just plug it into the standard form of the equation, which is x minus h squared plus y minus k squared equals r squared. Okay, so let's look at one. This one, it tells us our center. Since we know our center, I'm going to go ahead and label this as hk. And it passes through this point 1, 9. So I'm going to call that my xy. So the first thing I need to do is find my radius. My radius is equal to the square root of x minus h squared plus y minus k squared. Remember, this is just the distance formula. I just plugged in hk since that's what we always call our center point. So here I do the x value they gave us, which is 1, minus my center value, which is 4 squared, plus the y value they gave me, which is 9, minus my center y value, which is 8. That's my k. And then I simplify. So the square root of negative 3 squared plus 1 squared gives me the square root of 9 plus 1, which is the square root of 10. Okay. Now that I have my radius and I know my center, I'm just plugging those into my standard form. So I have x minus h squared plus y minus k squared equals r squared. So x minus my h value, which is 4 squared, plus y minus my k value, which is 8 squared, equals my radius, which is the square root of 10 squared. And then I just simplify. So the standard form of this equation is quantity x minus 4 squared plus quantity y minus 8 squared equals 10. Okay, not too bad. Let's look at one more like that, and then we'll get into how we use completing the square for circles. Alright, so the first thing I'm going to do is notice they already gave me my center, which is hk, and then it passes through this point, so I'm going to call this xy. I need to find my radius so I can find the distance between my center and this point. So my radius is equal to the square root of x minus h squared plus y minus k squared. I have the square root of x, which is 0, minus h, which is 0 squared, plus y, which is 8, minus k, which is 0 squared. So I end up with 0 squared plus 8 squared, which is just the square root of 64, which means that my r is 8. Now that I know my radius and my center was already given to me, I just use those two values and plug them into the standard form of my circle. Okay. So I get x minus my h, which is 0 quantity squared, plus y minus my k, which is 0 quantity squared, equals my radius, which is 8 squared. So I end up with x squared plus y squared equals 64. And I just leave it like that. So here's another one that I was talking about. If you end up with only an x squared and a y squared, that means that your center values for your ordered pair are zeros. That's the only time you don't see quantities being squared, is if you know, it's the same as doing x minus 0, y minus 0. All right, so those are pretty much all the types we're going to do where they give us the center, or they give us 2 points, or they give us a center and the point, and we have to figure out how to get it into the standard form. The next type probably are the more difficult, and it's because they give us an equation of a circle, but it's not in standard form. And to get it in standard form, we have to use completing the square. So here's a little refresher of how we're going to do it. First, we're going to rewrite the given equation, and I'm going to group my x terms together, and then I'm going to group my y terms together. Okay? And then whatever my constant is, I'm going to put constants on the right side. Like, I'm going to put them on one side of the equation all by themselves. Okay? Then I'm going to add the necessary term to each side to complete the square with the x and also the y. So we're going to do completing the square for the x's, and we're going to do completing the square for the y's. So once we do that, then the left-hand side should look like factored quantities. Okay, I'm going to just put here, using the shortcut, we get something like x minus h squared plus y minus k squared on the left. Okay. So remember, the shortcut is once we take half that middle term, whatever that value is the value that shows up in our squared quantity. And I'll show you that in a minute. Okay. And then we want to go ahead and write our answer in standard form, so we need to simplify the right-hand side. And then once we're done, we go ahead and graph the circle if it asks us to. Okay, this first one does. So let's go ahead and look at it. All right, so the first step is to go ahead and group my x's and my y's. So I'm going to write my x terms first. So I have x squared minus 4x. And then I'm going to write my y terms, and I'm going to do them in different colors just so that you can follow my process. Plus y squared plus 4y. And then remember, we want to move our constant term to the other side. So I'm going to go ahead and move this 8 over by adding, which makes this equal to positive 8. Now I'm going to go straight into completing the square, because notice my leading coefficients are already 1. So if I go into completing the square, I take half of the x term coefficient, okay, or my middle term. So I'm going to do half of negative 4, which gives me negative 2. And remember, this negative 2 is what I'm going to square and add to both sides. Okay? And I'm going to go ahead and highlight it, because when we use our shortcut, that's our shortcutted version. Okay, now I'm not actually going to do that yet. I'm going to go ahead and do y's, and then I'll write it all together. So I'm going to do the same thing for the y's. I'm going to look at the y coefficient, which is 4. I'm going to take half of 4, which is 2, and for the y's, I'm going to square this and add to both sides. So it's like completing the square, but we're doing it twice, one for each variable. Okay, so on the right-hand side, the left-hand side, we now have x squared minus 4x plus the negative 2 squared we got from completing the square. Then we have plus y squared plus 4y plus 2 squared, which we got from completing the square with the y's, is equal to the constant term 8 that we had, and then the 2 squared values that we got. The negative 2 squared from completing the squared with the x's, and the positive 2 squared that we get from completing the square with the y's. So again, remember, once we take half the middle term and we get negative 2 and 2, we square that and add it to both sides. So I showed it in blue. I squared negative 2 and added it to both sides. In brown, I squared positive 2 and added it to both sides. Now I'm going to go ahead and write this out a little bit just this one time, and then I'll show it with a shortcut. So my blue turns into x squared minus 4x plus 4, which if I were to factor, that would factor into x minus 2 times x minus 2, which then we could write as x minus 2 quantity squared. Okay, so if we go straight into our shortcut, remember, when we take half the middle term, whatever that value is, which in the blue case was negative 2, that negative 2 is going to be the number that shows up inside our squared quantity. Okay, same thing with our y's. I now have y squared plus 4y plus 4, which if I were going to factor, that factors into y plus 2 times y plus 2, which we can write as y plus 2 quantity squared. And again, using the shortcut, I could have just seen right away when I took half my middle term and it was 2, that 2 is what's going to be inside my y squared quantity. Okay? So notice on the left-hand side, we already have what looks like the standard equation for a circle. Now on the right-hand side, we just have to go ahead and simplify our constants. So I have 8 plus negative 2 squared, which is 4, plus positive 2 squared, which is 4. So when I write out my my answer, I end up with x minus 2 quantity squared plus y plus 2 quantity squared equals 8 and 4 is 12, and another 4 is 16. So this is the standard form of the equation of my circle. that I got by completing the square. Then the next thing I want to do is it says go ahead and identify the radius and graph the circle. Okay, so remember the radius we get by looking at the numbers inside my squared quantity. So this gives me my center. Remember when we get our center points we change the signs from the way that they look in the equation. So this means my center is 2, -2. And then I also need my radius, which I get by looking at this constant term. Okay, when it's written in the equation, it's actually r squared. So if r squared gives me 16, then that means just regular r has to equal 4, right? Or the square root of 16, which then gives me 4. So from my equation, I got my center and my radius, so now I can graph it. So I'm going to go ahead and go out 2 on my x-axis and then down 2 on my y. There's my center, and then my radius is 4. So I'm going to go out 4 units in each direction from my radius. And then all I have to do is connect my dots to get my circle. Okay. And I'm going to go ahead and label it. Here my center was 2, -2, and my radius was 4. Okay, so I just want to briefly kind of rehash what we just did. Okay, so completing the square, first thing we do is write our x terms first, our y terms second, our constant on the right hand side. Then we complete the square separately for both the x's and the y's. So for x's, I take half the middle term. Whatever that is, that's what's going to be in my highlighted quantity squared. But I still have to remember to square it and add it to the right hand side. Same thing with the y's. When I take half my y term coefficient, I can use the shortcut, and that number is what will be inside my y squared term. But I also have to remember to square that number and add it to the right hand side. Okay. Once I have that done, the left hand side I just use the shortcut. Right hand side I'm just combining my constants. Once I have the standard equation for the circle, I can easily identify my center just by looking inside my quantities, and I can find my radius by just taking the square root of whatever number is on the right hand side. And then I graph my circle. I'm going to do one more like this, and then I'll have y'all practice. Okay. So same thing here. I want to write my x terms first. So I'm going to write x squared minus 2x, and then I'm going to write my y terms, which is y squared plus 10y. And then I want to write my constant terms on the right hand side of the equation. So I need to move this 1 over by subtracting, which makes this equal to -1. Then I go ahead and start completing the square. So when I take half of my x coefficient, which is -2, that gives me -1. So I'm going to go ahead and highlight that so I can use my shortcut, and I'm going to go ahead and just say square and add to both sides. And then I want to do the same thing with my y. I look at my y term coefficient and I take half of it. So half of 10 gives me 5. Again, that 5 is what I'm going to square and add to both sides. Okay. So I'm going to go ahead and use the shortcut this time. On this side, since I have this highlighted -1, I know my x quantity is going to end up being x minus 1 quantity squared. I'm just going to put it over here using shortcut. Okay, and then I'm going to do the same thing with my y's. Because I know when I took half my middle term I got 5, my y quantity is going to be y plus 5 quantity squared. So notice, just using my shortcut to get those quantities. And then I do need to remember to add those squared quantities, squared values to the right hand side. So when I took half the middle term with my x's here in blue, I got -1. So I need to add -1 squared to the left. And then when I did my y's and took half the y term, I got 5. So I need to add 5 squared on the right hand side to accommodate for the y completing the square. And now I just simplify. So on the left I have x minus 1 squared plus y plus 5 squared equals -1 plus 1 plus 25. Notice my 1's are opposite, so those just cancel. So I end up with x minus 1 squared plus y plus 5 squared equals 25. So that is the standard form of this circle. And then I'm going to go ahead and identify the radius and the center and graph it. So here the center, remember I changed the signs of the numbers in the quantities. This gives me 1, negative 5. And then for my radius, I just take the square root of 25. So if this is r squared, then that means that r has to equal 5. So I plot my center, so I go out to 1 and down to 5. And then my radius is 5, so I'm going out 5 units in each direction. So 5, 5. One, two, three, four. I guess that's 5. Then look right. Okay, so then I just draw my circle. Okay, and then I'm going to go ahead and label my center and my radius. So my center here was 1, negative 5, and my radius was 5. Okay, so complete the square with the x's. Don't forget to add your squared term on the right. Complete the square with your y's. Don't forget to add the squared term on the right. And then you can use a shortcut to easily get the x's and y's into squared quantities. And then on the right hand side, all you do is combine your constants. That gives you the standard form of the center equation. I'm sorry, the circle equation. Then you identify your center and radius so you can graph it. Okay, so there's 3 for y'all to try. The first one is this completing the square, and then the other 2 are types like we did earlier. So I'll give you just a minute to work on them, and then we'll go over the results. Okay. All right, so on this first one, we're completing the square, so we get our x terms together, our y terms together, and we move our constant to the other side, which makes it a negative 4. We do completing the square with the x's, which if you use a shortcut, when you take half of negative 4, that's negative 2. So we can skip down and see that that should factor into the quantity x minus 2 squared. And then don't forget to add that negative 2 squared to your right-hand side. Then we do it with the y's. When we take half of negative 12, we get negative 6. Using our shortcut, we know that that's the number inside our y squared quantity. So we have y minus 6 quantity squared. And then again, don't forget to square that negative 6 and add it to the right-hand side. So we have our standard form of the circle on the left. On the right, we just combine our constants. Again, we have negative 4 plus 4, which just cancels out and leaves us with 36. So we identify our center and our radius, which by looking at inside our squared quantities, we just change the signs of those numbers, which gives us a center of 2, 6. And then our radius, since we know our radius squared equals 36, that means our radius must be 6. Okay. On the second one, kind of got a little nasty, right? They gave us the endpoints of a circle. When they give us the endpoints, we have to find the center, which is the midpoint between those endpoints. So we take the 2 endpoints and average their x's and y's, which gives us the middle point, or our center of negative 6, 3/2. Now once we have our center, we're going to use that point, and one of the points they gave us, which I just happened to choose the second one. If you didn't choose the second one, that's fine. And we're going to plug it into our distance formula, which also happens to be our radius formula. So we plug in x minus h squared plus y minus k squared, and then we're going to take the square root of it. Now notice once we get down to about the second step, we have a constant term and a fraction. So anytime we have a whole number and a fraction, we're going to have to get a common denominator, which I did, which was 2. So that leaves us with 11/2 in that squared quantity. And then once we get that squared, then we're also going to have to get another common denominator to be able to add the 1 to it. Okay, so I multiplied by 4 on top and bottom, so they both have a denominator of 4, which means my radius is the square root of 125 over 4. I'm not simplifying that because remember, when we plug our radius into our formula, it's going to get squared, so that radical is going to go away. So I know my center in purple, I know my radius in green. When I plug them into my standard form of a circle, I end up with x plus 6 quantity squared plus y minus 3 halves quantity squared equals 125 over 4. So it was the same process as the ones we did earlier. The only difference is this one was kind of nasty in terms of having to use common denominators, okay? Same process. Let's look at our last one, which hopefully was our easiest one. This one, they gave us the circle, and all we had to do was figure out the standard form. So in order to find the standard form of a circle, we have to know the center and the radius. So I go out to my circle, just figure out what my center point is, which here is 7, 7, and then I take that 0.77 out to the edge of my circle and count how many units it is from the center out to the edge of the circle, which here is a radius of 3. So now I know my center, I know my radius, so I just plug them into my standard form of my circle equation. When I do that, I end up with x minus 7 quantity squared plus y minus 7 quantity squared equals 9. Okay, now this is the end of E1.1, so you should now be able to do your E1.11 homework on My Math Lab. There's not a worksheet, it's just the regular homework on My Math Lab for this section. And this section completes the homework material for the first exam. So once you get this homework completed, there is a review that's under your course materials that you can print out and work on paper. The answers are already attached to it. It doesn't need to be turned in for credit. It's just to help you prep for the exam. And then your exam should be open. I think I have either already emailed you or I will email you soon to let you know what the dates are of the exam. If you have any questions, please let me know, and good luck.